your spread is bigger, okay, to make a sharper endpoint.
So I'm not familiar with KS. What's KS? It's I know KA, KB, KW, and KS.
S, well, for all these are equilibrium conditions, right?
So
the K is universal.
So
K, the equilibrium constant, is universal. S stands for solvent, okay, for the solvent, the chemical solvent. And KW, the W is specific, even more specific for the particular solvent, which is water. So it carries KW. While in here, then it doesn't make sense to call it Km, and then another one is Ke, so many. Just that water is so popular, right? When you talk about solvent, automatically you think of water. So KW, And there's no reason to memorize the Km or Ke, right? This value. You have a table to refer to, and therefore just look at the table solvent and correspond to the K of solvent. Okay. Okay, so now we can review some of the basic calculation. When look at that HCl, then it's a strong acid. So it needs a solvent to ionize. So in this case, whenever a solvent is not indicated, then it's automatically water. Okay, so it's completely ionized. So when you have 1 molar HCl per your calculation, then the 1 molar will be completely ionized into the corresponding ions. Okay, so 1 molar of that and 1 molar of that. So you know that. Then lower concentration is the same deal, So lower concentration, you get the whole deal into this species because you want to calculate for pH. Okay, so you want to relate to this concentration. So once you get the concentration, then remember the formula, then you can solve for the pH. So this you learn. There's no need to write down anything, right? You already know all that. Now switch to sodium hydroxide. This is a strong base, so-called strong base. Again, is completely ionized. So there's no K value for the equilibrium. So with this concentration, it completely ionized into the OH minus. So you can tell it's OH minus, right? So you take the minus log of that. What risk here is the POH. It's not your pH, right? So P function for the hydroxide concentration. So when I ask you for the pH, then it's going to be higher than 7 to be logical, because you realize this is a base. It cannot be less than 7, okay? So just a double check for your answer. Any question? Okay. Okay, so then for acid and base titrations, then when you pick a method, then the method will call for some of your common sense. When you pick a particular reaction, it needs to have an equation to describe. Okay, so the equation needs to have both the titrate and the analyte that they react with each other. So that's common sense, right? So once you balance the equation, then the ratio will be whole number. So be sure you pick an equation allow you to do all these. Okay, some equations are variable ratios. Then depends on acidity and all that. Then those are not good reactions. Okay, you want to have a fixed one. Okay, the second one is, once you pick an equation, be sure that you know that the reaction rate is rapid, so you can do the titration on the spot. if a slow reaction, then you may need to do back titration. Okay, but most people would want to do the titration on the spot. Okay, then how quantitative, how complete is the reaction is based on the K of reaction, the forward one that we talked about previously, that the forward reaction product of a reactant must be greater than 10 to the 8. Otherwise, may not be quantitative enough. Okay, then the fourth criterion is once you reach the endpoint is once you add a little bit excess of the titrant, then that titrant will be able to react with an indicator. So there must be a suitable indicator for the purpose. Or the titrant could be realized by using some kind of readout, such as electrode, okay, to monitor. Okay, so what it amounts to, this is also a reaction. So we will call this the second reaction. Okay. Okay, so here, the endpoint versus equivalence point. What's the difference? You know, endpoint is what you see practically. So it's experimental. So when you reach a color change, then you say, oh, I got the endpoint. Now, the equivalence point will be theoretical. It's based on the coefficient of calculation. Okay, so you add a quantity to your sample. Then when you have added a coefficient amount of your titrant to the to your sample, then you have reached the equivalence point. Okay, so this is per calculation according to the equation. Any question with all those points? Okay. Okay, next is that to carry out the titration, you will need to pick a suitable titrant, right? So once you pick a titrant, you will a chemical, then you will need to prepare your standard solution because your titrant is a known concentration. Okay, so you will want to pick the best chemical to make the titrant solution. So quote and unquote, how to define as the best chemical. So we will talk about that a little later. Okay, whenever you're dealing with the best, then there could be trade-off. So you have some criteria to go through, compare, and then just compromise. Okay. For example, the trade-off being, for example, the cost. Too expensive, like platinum is good, great, but it's so expensive. So I go with silver, but silver is still fairly expensive. Toxics, if you use something real toxic, arsenic, something like that, selenium, then you say, okay, no, I'm a nice person, I don't want to pollute the environment, so pick another one. So you don't want to use an explosive chemical as well, right? So things like that.